Hi friends, good morning to everyone. In the last session, we have discussed the concepts of functions in C++. We have discussed how to define a function. A function is defined using the syntax return type, function name, parameter list, then opening and closing curly braces. Within the opening and closing curly braces, we need to define the statements of the function. That means the executable operations should be placed inside the function definition. To define a function in C++, we need to declare a function. The function should be declared before the main function. For example, using the function prototype, we can declare the function. Say return type, function name, parameter list, then a semicolon. We can define any number of functions, right, following the main function. We can also define the function before the main function. That stage, function prototype is not required. Second, we have seen, right, how to pass arguments to a function. The arguments type, that means the parameters can be passed through to a function in a different ways. We can pass right zero parameters to a function. We can pass one parameter, two parameter, or we can pass any number of parameters to a function. We can pass right the values, or we can pass variables to a function. Then we have discussed right what is call by value. Call by value is a mechanism in which the actual parameter values are passed, right? Our actual parameters are passed in terms of value mechanism. So the formal parameters receive the value of actual parameters. The changes made inside the function definition will not reflect the actual parameters that are being used to make the function a call. That is the logic of call by value or pass by value. Then we have different. Then we have discussed the call by reference logic using the concept of pointers and using the reference arguments. Reference arguments are nothing but reference variables, aliases. Using alias, right? We have discussed the concept of pass by reference. Then a function may return a value to a calling place. When a function returns a value to a calling place, it may return, right, maximum one value to the calling place. In case if the return type is void, the function will not return a value to the calling place. If not, right, for the fundamental types are concerned, function returns maximum only one value to the calling place. In case if we like to return multiple values to the calling place, we can return the entire structure. So defining the structure and returning the structure variable, the entire structure, right, the entire members in the structure are going to be returned to the calling place. Then in the last class we have explored, right, what are inline functions. Inline functions are functions that are expanded in line to reduce the call cost of the functions. That means to reduce the function call overhead cost, we need to use the inline functions. Inline functions are useful when the function definition is very small. Inline functions will not work in some situations, right? Using for statement, functions with the returning values, switch statement, right? Or when the function definition is very large, inline functions will not be worked by the corresponding compiler. Then we have discussed right, the concept of default arguments. Default arguments to assign values to the parameters. Whenever we miss the actual parameter values, the corresponding values set in the default arguments are actually going to be taken place. Default arguments, the rule is that we need to set the values to the corresponding parameters from right to left direction. Right to left direction. That means we can specify right the values to the parameters from right to left direction. In case if we like, right, the entire parameters to be set some initial values, that is possible. We need to set all initializers in the corresponding formal parameters. In that stage, what will happen when we miss the entire actual parameters? All the default values set in the formal parameters are going to be taken place. That is the logic of a default arguments. So up to this slide we have discussed in the last session. Have any queries in that? Shall we continue, right? The next topics, function overloading and recursion. Say yes or no.
Yes, sir.
Okay,
Yes, sir.
very good. The next topic is a function overloading. I am changing to write this compiler version. Function overloading. This is one important feature of object-oriented programming. All of you please check, right, if the screen is visible. I am sharing the entire screen. Function overloading. Function overloading, this is one example of a compile time polymorphism. What is polymorphism? Poly, right, more than one, right, morphism, right, forms. So taking more than one forms is said to be the function overloading concept. C++ supports a function overloading concept. To achieve the function overloading, right, what we have to do means we need to define some additional tasks to a function. For example, considering a function void f, this is one function. Assuming the declaration is return type function name parameter is semicolon. Consider the second function, say void f1. This is one function declaration. Another function, say void f2 with some parameters, say int comma int. Another function is say void f3 which takes some parameters float comma char. Assuming that these are the function declarations, to call the corresponding functions, it is necessary to use the function name along with the parameter list. So clearly, the function calls will be f0 parameters, f1 with 0 parameter, f2 with 2 parameters, say integer 1 comma 2, f3 with the two parameters. One is a floating point quantity, second one is a character version. For example, these functions f, f1, f2 and f3 are going to be invoked using these calls. F with 0 parameter, f1 with 0 parameter, then f2 with right two integer parameters, f3 with floating point as well as character version. In this case, we are calling the functions separately using the function name. When we call right f of 0 parameter, the corresponding version to be called is this version. Calling f1, right, the unique version, right, f1 is going to be called. Calling f2, the version, right, f2 with the two integer parameters, int comma int, version is called. f3, right, this one, this f3 version is going to be called. So in this case, the function is called, right, by mentioning the corresponding function name along with the required number of parameters. This is a normal function call. we can provide some additional task to the function, right? How to define, right, a function that is said to be overloaded, right? In case if you want to say two functions, if two functions say f1 and f2 are said to be overloaded if and only if the function should satisfy some criteria f1 and f2. f1 and f2 must have the same name. Function name, right? It should be identical. So f1 name, right? It should be equivalent to f2, or f2 name, right? Should be equivalent to f1. Both names must have the same one. Second, the functions, right? f1 are the functions, right? Which is same as, right? The same name as f1 or f2. Functions should have same functions should differ the parameters. In what way it can differ the parameters means in terms of number of parameters, type of parameters, or they can differ both in number and type of parameters. As we discussed earlier, right, buy a ticket, right, at different situations, right, you will be working, right, accordingly. In the same way, here, only one function is going to be called. That stage, right, we can pass the number of parameters in a different way. The function parameters can be differing based on the number of parameters, type of parameters, or they can differ, right, both in number and the type of parameters. So first to understand that the number of functions to be required for function overloading is at least two. At least two functions are required for part one, function overloading. At least two functions are required for a function overloading. So having the functions right f1 and f2, right, their names right must be the same. So if we consider these examples, for example, first question, return type is void. Function name is, for example, f. Assuming that the declaration is given here, void f. Another function right f is also defined with the same name f. In case right the function f differs a number of parameters, for example, the number of parameter is say 1, right? This is integer 1. In this case, what we can say, these two functions, one with 0 parameter and one with 1 parameter, since these two versions are differing in their parameters list, in this case, these two functions are said to be overloaded. Since this condition is satisfied, functions should differ in the number of parameters. The basic condition is the two functions must have the same name f here also f. So in this case, what will be the flow of execution? When you call a function f with a zero parameter, the first version is called. And when you call the function with one integer parameter, the second version is going to be called. Understand? So only one name. The thing is, the number of parameters are going to be differ. So in this case, these two versions are said to be overloaded. See the second example. Suppose void g is defined with one integer parameter. Another one, void g is defined with a character parameter. In this case, what happens? Can you say the functions right g are going to be overloaded?
Yes, sir.
How can you say the function g is to be overloaded? Yes, the rules are satisfied. First one, f1 and f2 must have the same name because here the function name is g. Here also the function name is g. First condition is satisfied. If and only if, right? Or two conditions should be satisfied. Second one, the functions right differ in these cases, any of these cases, number of parameters. Here the number of parameter is 1. Here also the number of parameter is 1. When you have the same number of parameters, they can differ in their type, right? Type of parameters. Here the type is an integer one. Here the type is a character one. So in this case, when the number of parameters is one, they are differing in the type of parameters. So this version is said to be overloaded. Third one, consider this situation. Suppose void fetch. One version is try to say int comma long. Another version void fetch var comma int comma loop. Defining another version void fetch taking one integer parameter. See the number of versions right should be at least two. At least two functions are required to distinguish function overloading. What about the third version? Can you say the third version is overloaded?
Yes, sir.
How?
Sir, both the number and types of parameters varies in three functions, sir.
Very good. H. Function name is same. First one right differing in right to two parameters. Second version takes right to three parameters. Last version takes right one parameters. So clearly these functions are differing in the number of parameters. One parameter, a two parameter, and a three parameters. In that case, right, we can say the function is said to be overloaded. Now consider this scenario. Void, suppose I is a function, but takes float comma float comma float. One version. Another version void same function is defined I with character character int. Another version void I. Parameters are float, float, char. One more version void I int char float. Assuming these are the four function declarations are having the same name. Name is I. What about this case? Can you say these functions are overloaded?
Yes, sir.
Yes. Because a function name is same, the number of parameters, right? All are three. First version is three, second one three, third version takes three parameters, and the fourth version takes three parameters. When the number of parameters are same, right? They must differ in the type of parameters, or they can differ right both in number and type of parameters. So in that case, here this version is said to be overloaded. Consider this scenario. Void, suppose function name is fgh. This is one version. Then another version is say function fgh would like to return a value character to the calling place. What about this case? Can you say the version fgh is said to be overloaded? What about the rules? Function name, right, must be identical. fgh, okay. Then second one, the functions, right, should differ in the parameters. Number of parameters are in the type of parameters, or they differ both in number and the type of parameters. Here, first version takes number of parameter is 0. Second one takes the number of parameter is 0. In this case, only it seems the return type is differing one, right? So based on the return type, we cannot conclude the functions are going to be overloaded, right? So in this case, the versions fgh are not overloaded. So the important rule is return type alone is insufficient to distinguish function overloading. In this case, compiler automatically reports the error message. So based on this return type, we cannot check for the function overloading a concept, right? This will not be satisfied. Whatever the number of functions, void fgh, right, char fgh, right, float fgh, right, or double fgh, whichever is, right, when the number of parameters is same, right, number of parameters is 0, right, in this case, only one thing, the functions are differing in their return types, that results in the compile time error. Now let us see the rules of right a function overloading, right? First, the number of parameters, the type of parameters, or the function should differ in number of parameters, type of parameters, They differ both in number and type of parameters, having the same function names. This is the first one. What about the flow of execution means? First, flow of execution. First, a compiler tries to write a check or exact match. What is exact match? Whatever the types of parameters mentioned in the actual parameters and the type of parameters mentioned in the formal parameters, that should be checked for matching, right? So exact match in the sense that the type of actual and formal parameters are checked for the same data type. For example, here in the version number 4, void I float void I char int. So in that case, right, if you have specified, right, first one is float, second one is float, and the third one is a floating point version, then the actual parameters are matched with the corresponding formal parameters. So if there is an exact match, right, what happens? In step number 2, right, we are writing if one, right, succeeds. In this case, when there is a exact match between the actual and formal parameters, the corresponding overloaded version is called. Corresponding overloaded version is called. Suppose if one fails, assuming that the actual parameters are not matched with the formal parameters exactly. In this case, what happens? Right, that is the rule. If one fails, this is a role of a compiler to apply automatic type promotion rules. Automatic type promotion rules, if possible. So in this case, right, the automatic type promotion rules are applied. For example, in the version void h int comma long, you need to pass exactly, right, the two parameters. First one is of an integer one and the second one is of the long one. For example, void h int comma long, void h int comma long. This is the version. Assuming the function call is h of say 25 comma one long integers, right? Sorry, 10 L, right? You can write or 10 capital L, right, to indicate the long integer. So in that case, right, no problem. The parameters are exactly, right, matched with the formal parameters int comma long. Actual parameters are matched with the corresponding formal parameters int comma long. So this version is called. In case the function call is h of 1 comma suppose small e, in this case what will happen? Can you predict the scenario in this case? How will be the flow of execution? In this case, you need to assume that the version, right, int comma char is not available. Assume the version h of int comma char, this is not available. In case int comma char version is available, no problem. Int comma char version will be called. This is a rule. Since already we have int comma long version, int comma char is different from int comma long version. In this case, right, when h of int comma char version is not available, assuming int comma long version is defined, so compiler tries to apply the automatic type promotion rules. So what are the automatic type promotion rules? Character is converted to integer. Character is right further converted to right integer to float to double, right, or integer to long. Because these are numerical types, right? Compatible types, character and integer, compatible types. The equivalent ASCII value is taken, right? So h of 1 comma, this is 1, right? This is 1 comma a means, what is the ASCII value of small a? What is the ASCII value of small a? Make it fast. ASCII value of small a is none of you are
97.
responding. 97, very good. So since the ASCII value of small a is 97, in this case what will happen? This is 97, right? 97 is the integer quantity. Character is first converted to the integer quantity, and then right integer is right further type promoted to the long type. So 1 comma 97, right? 1 is the integer quantity, 97 is the long variable. So in this case, the automatic type promotion is succeeded. The corresponding version to be called is void h int comma long, right? So this is the rule. If one fails, when compiler tries to apply the automatic type promotion rules, right? In case if the type promotion is applicable, then what happens? The right version is going to be called. In case if there is a mismatch between, uh, if there is no type promotion is applied, that means when there is a mismatch between right the actual parameter to the formal parameters, in this case compiler reports what one? Compiler reports error message. When the actual parameters are not type promoted to have the equivalent formal parameters. That stage, right, what will happen means compiler reports the error message. That means when there is an exact match, no problem. If the exact match is not found, right, automatic type promotion rules are checked. And in case the automatic type promotion is succeeded, no problem. The right version is going to be called. If not, the compiler reports the error message. In the case of right when applying the automatic type promotion rules, there is a chance of right converting the actual parameters into the formal parameters that may match for multiple versions. For example, here right we meant a right a character 1, character is right converted to integer 1. So assuming that void which int comma int version is there and int comma long version is there, in that case right we have the problematic situation. Hope you understand. Additionally, right, if we have right one more version, void h int comma int. So by passing the second one is a character one. Character is a type promoter to the integer one. Integer is further type promoter to the long integer one. In that case, right, there is an ambiguity between the function calls. The ambiguity between the function calls are h of int comma int versus h of int comma long, right? So this is the ambiguity, right? A confusion whether compiler is right trying to call int comma int version or int comma long version, right? That is a problem from the actual parameters int comma char. These are the rules of right, a function overloading. Let us try to verify these rules with an example. Consider right this example, function overloading. Rules include the header file hash include iostream dot h. Then let us define the functions here, void f, then void f with one parameter say int, then void f int comma char version. Consider the main function int main. Define the functions void f. Inside the function f, right? Let us define one message. For example, cout listen function f is called listen endl. The manipulator is given. Closing curly braces. First version f is defined. Define the second version void f int suppose a. Because this is a function definition, we need to provide the formal parameter list, right? Data type variable name. Cout listen. Let us print the value of a. A is equal to a listen endl. We are just printing the value of a, right? Next, consider the third overloaded version void if one is int and another one is character. In this case, try to print the values of a and ch. A is equal to a, then ch is equal to listen ch listen a and n. The function is close to zero. Right? The three functions are declared overloaded versions, one with zero parameter, this version, and this version takes one integer parameter. So clearly the first two versions are overloaded, and the third version, right, takes two different parameters or simply two parameters, right? Here this is one parameter, and the first one zero parameter, and this is two parameters. So clearly these functions are differing in the number of parameters 0, 1 and 2. Clearly the functions f are said to be overloaded. So these three versions are said to be overloaded. Let us verify this result by calling the functions, right? F, second one, suppose f of 100, third one, f of int comma character, right? Suppose 10 comma character is e. Then finally return 0. Let us save the file. File, save. Previous file name is CEXX14, I think. Let us try. 14 is already available. Is CEXX15. Compile the code F9. I have pressed F9. The compilation is succeeded. Now pressing Control F9. What happens? Calling f of the function f is called, right? The result is right, function f is called. Then void f of int. When passing the integer value 100, this integer version is called. So you can see the message a is equal to 100. Then f of 10 comma a, right? In this case, what happens? A is 10 and the character ch. Ch is set to a. Don't confuse, right, the character, the ca with right, the local variable. The character ch is assigned a value small a. So small a is printed here. Ch is equal to a. Now in this, right, we can conclude that there is a exact match between the actual and formal parameters. In case, right, I define one more version here, void f int comma int. In this case, what happens? Can you say these 4 versions are said to be overloaded? Please answer.
Yes, sir.
Good. Because this is 0 parameter, here 1 parameter, here 2 parameters, again 2 parameters, and the number of parameters are same. They are differing in their type because here the order is int comma char. The second version, the order is int comma int. So clearly int comma char is different from the versions int comma int. So the versions, right, 3 and 4 are said to be overloaded. 1, 2, 3 are overloaded, right? So clearly 1, 2, 3, 4. All of these 4 versions are overloaded. So to define, right, this version, here let us define the function void f int comma int. Suppose int a comma int b. Here I am writing to print the values of a and b. How to write the cout statement? Cout listen double quotes a is equal to listen a listen say slash t b is equal to double quotes listen b. A and b are printed, right, in the usual style. Call the function f of int comma int. Here passing the actual parameters. Suppose f of 1000 comma 2000. Let us save the file. File save. I have pressed F9. The code has been compiled successfully. I am pressing Control F9, running the program. Have a look into the last line of output. Simply f of 1000 comma 2000 results in the call, right? The last version a is equal to 1000 and b is equal to 2000 because the rules of, right, the function overloading, when there is an exact match, when the actual parameters are matched with the exact formal parameters, that stage the right overloaded version is called. Actual parameter is int comma int, so int comma int version is called. Within this int comma int version we have printed the values of A and B. So A is equal to 1000 and B is equal to 2000. Understand? Suppose we like to provide some other values, right? To check for the automatic type promotion. Suppose we have another function void if say a float comma a float. In this case, defining one additional function void if float a comma float b, printing a message cout less than I give the message in short float comma float version less than endl. To call this, we are passing the values f of 1.5 f as a floating point quantity, comma 1.9 f as a floating point quantity. File has been saved and compiled successfully. I am pressing Control F9. Seeing the last line, the call f of 1.5 f and 1.9 f results in the version, right? Float comma float. This means the last function call called the version float comma a float. Now have a look into the new function call f of. I like to pass the actual parameter, right? First one is a character version. Second one, first one is a character version. Second one, say the integer version, a comma 10. In this stage, what happens? F of a comma 10. Running the code, alright? Capital A, right? This is a character version. Character version is not available. In this case, character comma int, char comma int is not available. So char is the first type promoter to the integer one. So it checks if the integer version is available, right? Int comma int. Hope you understand. Int comma int version is available. In this case, int comma int version, I think the third version, prints the contents of A and B. So it seems the values of A as 65, B as 10, because capital A, right? The ASCII values 65, 65 is taken. So here what happens? Type promotion rule is applied. Type promotion rule is applied. Understand or not? Say yes or no.
Yes, sir.
Now consider another situation. For example, I like to write another program. File save. What's time now? Okay. In case one version is void f of int comma int. Another version is float comma float. I am commenting on this version. Void if int comma char version is commented out. Here also I am commenting this version. In a single line we have written a function, so I put a single line comment. So total function is commented out. Now calling a function f of a comma 10 as character comma integer 1. In this case, the value to be called is, right, the value, right, capital A is passed as a parameter to this integer version, and 10 is passed as a parameter to the integer version. So int comma int version is called. In case if we call f of capital A comma capital B, file save, control F9. A is 65, B is 66, because this is a character 1, character is type promoter to integer 1, and B, right, this is type promoter to the integer 1. Having another version, void if double comma double, assuming the double version is defined, void f double x comma double y, cout less than double comma double version less than endl. In this case, right, I am commenting, right, the integer version completely, f of 1000 comma 2000, f of this version, the int version is commented out. Having two versions, right, one with float and another one is double, float and double. So trying to call the version f of 10 comma 20, and it predict what will be the error message. I have already said, right, what will be the error message. Anyone predict? Int comma int version is commented out. There is no int comma int version, but we have, right, float and double versions. Actual parameters are integer 1. In this case, the integer will be, right, a type promoter to a float as well as double 1. So we can see the ambiguity error message. The ambiguity error message here, a linker error 10 comma 10. What is the value? 10 comma 20, integer comma integer version. No int comma int version is there because the version has been commented out. Float is there and double is there. So integer may be type promoter to, right, both float as well as double versions. In this case, right, you will be getting the ambiguity error, right? So with this, right, let us complete, right, the function overloading concept, right? We will continue, right, the concepts, right, in the next session. If you have any queries, you can ask me. Have any queries?
No, sir.
No, sir.
Okay, thank you very much. We will discuss, right, function overloading and the extended rules with ambiguities, right, in the next session. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.